Thanks, Lorenzo. So I will use this opportunity with the good introduction that you have given, and I don't want to repeat what you have said because the rules are the same on your end, on our end. So I will use that to raise a bit the ICT flag. And you have heard we are collaborating together on this topic, Factories of the Future, ManuFuture. You have heard it from Herbert von Bose, you have heard it from Antti Peltomäki. And I will give you a bit of our positioning here. And I will start with maybe the global positioning, and then Rolf will give you a couple of details on the program. So I'm primarily talking about the part of the program which is the first of the 6 topics under leadership in enabling and industrial technologies, so what was called LEIT. So I'll give you some information on that. How do I get the next slide?
Oh, sorry. Here you are. That's the right arrow. Sorry.
Okay, so that's what I'm doing. So I would like to put in context what we do in ICT and what is our vision that we have and that we are putting into the program. So yes, we are driven by the roadmap of EFRA, but this is money that comes from, funding that comes from the ICT topic there, so I'm trying to put that into context. So first of all, ICT from our perspective is a key enabler for modernizing Europe's manufacturing capabilities. And I will substantiate that comment a bit later. And you have heard that before, for example, from Herbert this morning. And we are collaborating with DG Research on this topic. But I strongly believe that without ICT, we would have a lot of problems. So ICT is a key enabler. And research and innovation in general is a strong pillar in the EU industrial policy that Antti Peltomäki has explained this morning. So I would like to give you 4 examples of issues that we have where ICT is a key enabler, or better to say, where without ICT we would not be competitive in future. So first of all, first one is innovative high quality products at competitive prices. I mean, we are good in Europe at innovative products, also at high quality products, but we have to be competitive in a way. You see that, for example, our car industry is competitive because the prices are still okay because of the high quality. You see other sectors, you have recently seen it in the news on, for example, TV production in Europe. Yes, there we have high quality, very innovative products, but probably prices are a bit too high to get the consumer to buy these products. So competitive price is quite important, and altogether ICT is supporting that. Second point I would like to make is high productivity, less energy, less waste, less natural resources. Lorenzo has given you some numbers on that. I will not go into the numbers here. The other one is, and that I think is a key one where ICT helps, is towards personalized, diversified, but mass-produced products, like through 3D printing, but also through CAD, modeling and simulation technologies. And as Mr. Hedenborg has said this morning, related to the digitalization as an enabler for manufacturing. So ICT is contributing to the Factory of the Future in FP7, has contributed around 250 million euros. That's around 40% of the Commission contribution, and we plan to continue along these lines in Horizon 2020. Now, when I give you this slide was just some examples of where we see ICT in manufacturing. I'm not just picking these examples, but I picked them because in these areas, EU suppliers are very strong on the world markets, and in some cases also or even leading the world markets. And here I would like to mention photonics and laser-based manufacturing. I would like to mention robotics and the smart part of robotics, robots that are able to interact with humans and robots that are able to learn. And there, you know, ICT is a key ingredient. Further, cyber-physical systems, for example, for process optimization or for the optimization of process chains. We have heard this morning from Heinrich Flegel when he talked about the system view. There we see cyber-physical systems in our products, like for example in the Mercedes car that you have introduced this morning, but as well cyber-physical systems in our production lines and in our supply chains. So these are key enablers there. And last not least, also the modeling and simulation analytics technologies that are ICT supported. For example, you need a lot of compute resources on that, high performance compute, embedded computing resources in order to do that, and to optimize the design, the production, and the supply chains. So what we have done in the past, I think Professor Westkemper has described already quite a lot. I would just like to say we have in the past funded 3 groups of projects, of research projects. Digital factories, first time right, made in Europe is our slogan for it that we have developed when we looked at the preliminary outcome. Smart factories, factories from computers, and virtual factories, managerial control through the cloud. So these are the research projects, the 3 research clusters that are going on in ICT, and we plan to have continuity on these topics, but Rolf will tell you more about that. Now, I'm very happy that before Maurizio Gattiglio has already mentioned I4MS. I'm very happy about that because I'm the one who planned and started I4MS, and I see that even it has only started 1st of July, it already got some attention. But with all these Vorschusslorbeeren, as we say in Germany, we now have to show that the concept works, and we will do everything to show that. Let me just explain you one basic idea of that. It's not just looking backwards now, because we have started it, but we will put about half of the funding that we have put already, 77 million, now we put about half of it again, probably in the second Horizon 2020 call. So it's worthwhile to look at the concept. So what we're trying here is to help our suppliers to cross the chasm. That basically means to support them in crossing this valley of death when they have to go from a research prototype into the market, to have to broaden their product, to make it use in many, many domains. And many of the suppliers around the world die when they try to cross this valley of death. On the supply, on the demand side, we want to support users gaining a competitive advantage through using advanced technologies. So it's a well-balanced supply-demand side measure that we are doing, and this curve, which everybody knows, I think is helping us to get there. Now, what does it do? We primarily want to support SMEs in here, and we have heard that, yes, it's an SME measure, but why is it special? I mean, in some programs we give money to SMEs, but I think SMEs need much more than money. They need funding, obviously, yes, and this is the direct financial support we are giving to them, but they also need technology, and they need competence transfers from those who know these technologies. So we give them, we have the centers involved, we have all the actors involved who can help them on that, and they need also access to competences in markets in Europe, across Europe, because they are normally located in one region and have no access, so they need that in a much broader scale. And we are supporting at the moment in I4MS 4 areas, and I would like to pick up Professor Westkemper's remarks before. We are working on some of that, like for example on HPC cloud-based simulation services. We are really looking at a European cloud and take into account the security requirements of European industry. Whether we achieve it fully with this first set of projects, we will see. But we are at least addressing the needs of SMEs there. So we have 3 projects there on cloud-based simulation services, one on advanced robot solutions, another one on intelligent sensor equipment, and one on innovative laser applications. And in total, we are planning to fund around 150 experiments clustered around network centers of excellence in these 7 networks together. So that's the basic idea of I4MS. Before I conclude and hand over to Rolf, I would just like to make one remark for tomorrow. Tomorrow, I understand you discuss as well smart specialization, and I would like to make one ICT-specific remark on that. Yes, in smart specialization, we see a concentration of actors along value chains in a few lead regions in Europe, and we also see that other regions cannot really create value from that. So it's a good concept because we get strong in some regions, but others may not get that strong or may lose. So in a smart specialization strategy, we are pooling EU resources, national resources, regional funds in large pilot projects like the ENIAC pilot lines or so. But there are other concepts that are possible and that can help to have others also to participate in value creation. When you look, for example, at virtual value chains, we can with the help of ICT, we can create virtual value chains, for example, on the development of software. There's no need that the software developer sits directly in the region where the manufacturing is taking place. So we can support ICT-enabled collaboration beyond regional boundary, which are geographically independent, so less developed regions can also participate in value creation. And also we help a little bit on the problem of not having enough skilled labor forces, because we can bind also labor forces from elsewhere of these lead regions without making them move, for example, to Stuttgart, München, Torino, or the Paris region. Now, I would like to use this slide to hand over to Rolf quickly. What we contribute from the ICT topic under Leadership in Enabling Technology and Industrial Technologies is a direct contribution to the Factory of the Future PPP, which is all driven by the EFRA roadmap. And there we have planned, and as Lorenzo said, it's all tentative, but we plan to have around 102 million in the first work program 2014-15. We are only indirectly contributing to the SPIRE PPP, but only indirectly may not be that bad, because when you look, for example, what we plan on modeling, simulation, analytics, this is as well valuable for manufacturing, for factories of the future, and as well for SPIRE. So I would not see that there is a big difference in terms of how we have phrased the program. Also, don't forget that in the Artemis joint undertaking and ENIAC joint undertaking, which is now merged to the EXCEL, European Components and Systems joint undertaking, there are many areas where your community can profit as well. I would like to give the example of Arrowhead. That's one of the large pilots in Artemis with around 70 million euros, and that's for the process industry primarily. So that's in the core of what is done in SPIRE. And last not least, I would like to say that also many activities that we see happening in the Photonics 21 public-private partnership and in the EU robotics public partnership is directly applicable and used in manufacturing. So Rolf, if you could give us some details now on the FOF PPP and the Connect contribution there, or the ICT contribution.
Okay, thank you. Yes, good afternoon, almost good evening. There's almost 1 minute left. What happened now to? Okay. We are at the end of a long day, and we are at the end of a long work program discussion. But concerning the work program, I think we see the light in the tunnel. So I think we know we most or less it has stabilized, and we're hoping to close it in time by December this year. So for the last speaker, what should I do to keep your attention up and to make it more interesting? I will repeat some of the issues said this today, and I will give you some appetizers to bridge it for tomorrow. First of all, you know Horizon 2020. The three pillars, the excellence in science, the societal challenges, and there's the light with the 17 billion funding for Horizon 2020. Within that light, it was said already, you have one pillar or one sub-program called Factories of the Future with 14 topics. And among which, these 14 topics, you have 3 topics for the work program 2014-15 on ICT, and I will primarily concentrate only on the first objective, FOF 1, which will be called in 2014 with a budget of 34 million euro. Yes, how did we come to the work program? First of all, we start with the vision. You always start with the vision, it's very good. So we had a vision on Factors of the Future, on ICT. There was a vision called Action Plan T, and there's a more recent vision called Industrial Landscape Technologies 2025. So from the vision, we have a strategy, and the strategy is to map the vision, the main findings of the vision towards the EFRA roadmap, and then to implement the roadmap via the research and development programs. The new thing in Horizon 2020 is to have an integrated approach between research development and innovation. Yeah, innovation should be the big thing because it's going closer to the market. We have some new types of instruments like the I4MS, and we have to rely on local infrastructure and local innovation multipliers, otherwise we will not have any impact. So the innovation is one of the most exciting parts and the newest parts which come in Horizon 2020. But as said, the approach is to have vision and strategy and then to implement. The industrial landscape vision 2025 talks about a globalized economy in 2025. Energy and sustainable industries, informed, influent society, personalized goods and services based on advanced ICT enabling manufacturing and production systems. If you look at that vision, within that vision on the ICT scope, they talk about digital factories. I think Professor Westkamper talked about that you have digital design tools, you have digital production, and that all has to come together. And the machines will benefit from more computing capacities. They will do more data processing and deal with more complex events in real time and will retrieve information from outside, from other management systems, from the internet, and from the global process chain. One of the main complexest challenges for globalized economy will be the higher complexity of the logistics supply chain. So value chain integration is one of the key topics in that vision, as well as human-centered factories. We discussed it already today, as well as how to deal with an increasing amount of data that will be retrieved from all little devices and processes and will be stored everywhere, and what to do with that and how to extract knowledge out of that. Good. From a vision, we move to a strategy. I think it was briefly said already today. This is part taken from the EFRA roadmap, where ICT has been identified as an enabler. And within that, we defined an ICT scope. And we did this sort of branding, calling it cyber-physical system. You heard about it already. And we talk about, as a topic for 2014, we aim at platforms for value chain integration for logistics and supply chains. Later on in 2015, we call for cloud services, high-performance computing, big data, and data deluge. The impact for the first objective will be how to deal with the connection of systems and machines to a large extent, which could lead to more decentralized manufacturing automation systems with less overhead, with higher agility and flexibility, and which will be capable to deal with increasing variance of products to respond to more volatile markets with a maximum productivity. Good. From a vision and a strategy, we have to implement something. We have to define the research priorities for 2014. As said, we're living in a more complex world. So systems and devices, machines are connected, and the connections are not more deterministic anymore. The control is not planned or from upfront, and there are much more interactions between the different devices and systems. So monitoring control is not the same structured topology as we had it in the past. And there's a study from IDC from last year predicting for 2020 there will be 31 billion of devices sending data to sort of a database to other systems, 1.3 trillion tags and sensors, and there's a prediction of having 25 million apps where information will be used to extract knowledge and to make decisions. That has been somehow taken as a baseline for the work program, and the work program, the objective of one, the outset you see over here, it has 3 research topics and 1 support action. There's no predefined budget for any of the research topics, so they're all equal. And the first one deals with more sensors and more sophisticated ways of sensor measurements at machine level. To have scalable architectures for adaptive and smart manufacturing systems, to deal with optimizing the process for modeling and simulation in real time, to combine that with real-time sensing measurements, and to have semantic access to functional features and data at machine level. We want to introduce the concept of CPS models and architectures, which would allow to go beyond the decision-making at the machine, the data of the machine, and also take into account data from other systems, from other machines to optimize the process. The second part is dealing with data beyond the machine, beyond the intra-plant, including extra-plant processes covering the whole process and supply chain, towards platforms and tools for process optimization of manufacturing assets, and towards a cloud-enabled manufacturing business web, what we call it. Third part again is about sensors, sensing and monitoring of fast, and this time laser-based processes in manufacturing in order to have a real-time feedback and optimization of the process parameters. Good. Cyber-physical systems has been introduced in the work program, and I want to hint you as an appetizer for tomorrow. There's a session W2.6 called Service-Oriented Architectures for CPS Backbone. We also talk about cyber-physical systems over there. We tried to slowly introduce the new term. It goes beyond the traditional system engineering. As traditional automation control processes will have to take into account information from the outside of the process, the outside of the machine, from interlinked processes. We call it physical world, takes information into account from the internet, from internet-based systems, and from back-end simulation and modeling systems. The data will be the key for the success of the new services of the new optimization process, and it will be key to visualize the data, to have a simulation and a virtual representation of the modeled data, and to feed it back to the physical process. So data is a key, and we expect a new balance between the 4 dimensions of manufacturing, including capital, energy, labor, and here with the CPS, we have a new way of knowledge creation. With that, I'm at the end of the presentation, and that is the first objective and the only one from the ICT part in 2014. This event is one of the events where we start to promote the topics, and there will be others. There will be on the 29th and 30th of October, there will be a workshop on, again, cyber-physical systems with one-day session on CPS for manufacturing. And on the 6th and 8th of ICT of November, we have at this place the ICT conference. Before the Info Day on the 16th and 17th of December, the PPP FOSPIRE Info Days in Brussels. So on the ICT Info Day, we will have one full morning only dedicated to ICT for manufacturing. So we also see here an increasing importance, increasing attention brought to the theme of manufacturing. It went to the political agenda on all levels. With that, I thank you for the attention, also for the last end session.